Welcome to the deep dive. Today, we're really getting into the nuts and bolts of Python, specifically for cybersecurity.
That's right. We're talking functions, modules, and crucially, how to write code that people can actually understand.
Exactly. We've looked at some great learning materials focused on these core ideas and how you might apply them to, say, digging through security logs.
hmm
So our mission really is to pull out the essential stuff about these Python building blocks.
Yeah, showing how they help create code that's efficient, clear, and, well, more secure in that cybersecurity context.
Okay, let's start right at the beginning then. Functions. What are they, really? And why should you care, especially if you're working in security?
Well, think of a function like a mini program inside your program. A reusable recipe, maybe?
A recipe, okay.
You find it once, give it a name, and then you can just call that name whenever you need to perform that specific task.
Ah, so it saves repeating code.
Precisely. In cybersecurity, you're often doing repetitive things, right? Like parsing different log files, looking for the same suspicious pattern. Yeah, Definitions let you automate that. You write the logic once, put it in a function, and reuse it. It saves a ton of time and, honestly, cuts down on mistakes.
Okay, that makes sense. So, how do we actually make one of these recipes, these user-defined functions?
It starts with what's called the function header, a specific line.
Right.
You use the keyword def, D-E-E-F, then the name you want to give your function, followed by parentheses, and then a colon bad.
Okay, def name parentheses colon. So like def check suspicious login.
Exactly like that. And actually, that name is important. The sources make a good point. Use descriptive names.
Ah, like a pro tip.
Yeah, you could say that. Check suspicious login tells you a lot more than, say, func1. It makes your code understandable, which, is vital in security. Misinterpreting code could be bad news.
Very true. Okay, so that's the header. What's next?
Next comes the function body. This is the actual code that does the work. The key thing here is indentation.
Indentation, right. Python's picky about that.
It is. The entire block of code that belongs to the function must be indented, usually 4 spaces. That's how Python knows it's part of the function.
So for our check suspicious login example,
You might indent the next line and have something like print, investigating suspicious login attempt. Yeah. That print statement is the action.
got it. Header defines it, indented body does the work. How do you make it run?
You just call it, use the function name followed by those parentheses again. So just check suspicious login on a line by itself.
And Python just jumps to the def block, runs the indented code, and comes back.
Exactly. It executes the body and then continues from where you called it.
The sources had a good example, I think, with checking different system statuses.
Yeah, that's a nice illustration. Imagine you have variables like application status and email status.
Mm-hmm.
You could use if statements to check them, like if application status unusual activity.
Yeah.
Then on the next indented line, you call your function, maybe flag potential threat.
And you could do the same check for email status, calling the same function.
Precisely. You reuse flag potential threat. If you need to change the warning message later, you only change it inside the def block once. Super efficient.
That's a big advantage.
Yeah.
Now, the sources mentioned a potential pitfall. Something about infinite loops.
Ah, yes. Recursion without a base case.
Basically, if a function calls itself from within its own definition.
Like def oops?
Exactly like that. If there's no condition to make it stop calling itself, it'll just loop forever, or until your program crashes. So definitely something to watch out for.
Good heads up. So key things. Header with def, indented body, call it by name with parentheses,
Mm,
and be careful with self-calls.
you got it. Now, often functions need some information to work with, right?
Yeah, like telling the recipe how many cookies to make.
Sort of. That's where parameters and arguments come in.
Yeah.
People mix these up sometimes, but they're distinct.
Okay.
Parameters are the variables you list inside the parentheses in the function definition, the def line. They're like placeholders.
Placeholders. So if you define depth remaining lodge and attempts, maximum attempts, total attempts, those two names, maximum attempts and total attempts, are the parameters. They signal the function expects 2 pieces of data.
Okay, parameters are in the definition, so arguments are...
Arguments are the actual values you pass into the function when you call it.
Ah, the real data.
Exactly.
Yeah.
So if you call remaining lodge and attempts 3,
Right.
2, then 3 is the argument for the maximum attempts parameter, and 2 is the argument for total attempts.
So the function can work with different numbers each time you call it. Makes it flexible.
Very flexible. Critical in security where conditions change.
Right. And functions don't just take data in, they can send results back out too.
Yep, using the return statement. Just the word return followed by the value you want to send back. No parentheses after return itself.
Okay.
So In our remaining login attempts function, we could calculate the difference and send it back.
Okay.
Return maximum attempts, total attempts.
And the calling code can catch that return value.
Absolutely. You can store it in the variable. The sources show this well. Remaining trees, remaining selection attempts. 3.
So remaining site trees would become 2.
Correct. And then you could use that variable. Like if remaining trees equals 0, print, account locked.
Very useful. And return also stops the function right there.
It does. As soon as return is executed, the function exits. Any code after the return inside that function won't run.
Good to know. Okay, another variable thing. Global versus local. What's the deal there?
It's all about scope. Where a variable lives or can be accessed, global variables are defined outside any function.
At the top level of the script, maybe?
Often, yes. Like device weight 7add 2130 BD. You can usually access that device height from anywhere inside or outside functions.
Okay, seems convenient.
It can be, but relying too heavily on globals can make code harder to track, especially in big projects. Things can get modified unexpectedly.
Right, so local variables.
Local variables are defined inside a function. This includes the parameters we just talked about and any other variable you create within the function's body.
And they only exist inside that function.
Exactly. Once the function finishes running, those local variables disappear. They're temporary.
Ah.
So in to set greet employee name message, welcome plus name. Return message, both name, the parameter, and message are local to greet employee. You can't access them from outside.
Which helps keep things separate and less likely to interfere with each other.
Precisely. It's good practice. And the sources strongly advise avoiding using the same name for a global and a local variable.
Oh, Python allows that.
It often does, but it's confusing. If you have a global username and then define a local username inside a function, the function will use the local one. It can hide the global variable and lead to subtle bugs.
Yeah, I can see how that would be tricky to debug, especially during a security incident.
Definitely. The sources showed an example. If you have a global username, a Larson, and a function identifies user that just tries to print username, it'll print a Larson. But if you then change the function to def greet, username localizer, print username, calling greet, will print localizer.
Wait.
Crucially, the global username variable outside the function remains a Larson. It hasn't been changed.
So the function created its own separate username. Interesting. It didn't modify the global one unless you explicitly tell it to, maybe.
Right. There's a global keyword for that. But generally, it's better practice to pass data into functions using parameters and get results back using return. It's much clearer.
Makes sense. So, takeaways. Parameters are placeholders. Arguments are the real data. Returns send stuff back. Global variables live everywhere. Local ones only inside their function. And be careful with naming.
You've got it. Now, besides the functions you write, Python comes packed with ready-made ones.
The built-in functions.
Exactly. They're just there, ready to use. No import needed for these.
Like print. We use that all the time to see output.
The classic example. And print is quite flexible, right? You can give it multiple things separated by commas, and it brings them all out.
Yeah, like print alert, event type, at timestamp. Very handy.
Another super useful one is type. Give it any variable or value, and it tells you its data type.
So type security will tell me it's a string.
Yep, it would return class string. And type 100 would give class int. People often wrap it in print, like print type my variable, just to quickly check what they're dealing with during development or debugging.
Okay, what else? The sources mention max and min.
Right, pretty self-explanatory. Max finds the largest number in a set of inputs. Min finds the smallest.
And you can give them multiple numbers or like a list of numbers.
Both work. You can do max 10, 5, 25, or if you have session lengths equals 15, 5, 62, you could do max session lengths.
Which would be 60. Could be useful in security, maybe finding the longest login session time.
Exactly the kind of application the sources suggested. Finding outliers or extremes, alien, works the same way for the smallest value.
And sorted. That sounds useful too.
Very. You give sorted an iterable like a length or even a string, and it gives you back a new list with the elements sorted.
In order, like smallest to largest for numbers.
By default, yes. Ascending order for numbers, alphabetical for strings. If we used our session lengths list, sorted session lengths would return 2, 5, 15, 60.
And the original session lengths list stays the same.
Correct. Sorted doesn't change the original. It creates a new sorted list. That's important. Also, a quick note. Sorted Usually expects items it can compare, so trying to sort a list with mixed numbers and strings directly might cause an error.
Good to know. So lots of handy built-in tools readily available.
Definitely. They save you from reinventing the wheel for common operations.
Okay, but sometimes the built-ins aren't enough. We need more specialized tools, right? That's where modules and libraries come in.
Exactly. Think of a module as a Python file, doing
Hmm.
Py, filled with code, usually related functions, variables, maybe classes that someone else wrote for reuse.
In a library.
A library is basically a collection of related modules. Python comes with a huge built-in collection called the Python Standard Library.
Standard library, so it's included with Python.
Yep. And it has tons of useful modules for all sorts of things, including cybersecurity. The sources mentioned read for regular expressions.
Crucial for searching text logs.
.csv for handling CSV data, OS and glob for interacting with files and directories, and time and datetime for working with timestamps.
All sound very relevant. You also mentioned a statistics module.
Yes, that's another useful one in the standard library. It has functions for common statistical calculations, like mean for average and median for the middle value. Useful for analyzing security data trends.
Okay, so how do we use the functions inside these modules? We can't just call them directly like built-ins, right?
Correct. You need to import the module first. The most basic way is import module name. So import statistics.
Just import statistics.
Yeah. To use a function from it, you use the module name, a dot, and then the function name. So statistics.mean, my list of numbers.
Module name dot function name.
Got it. So you'd calculate the median. Similarly, statistics.median, my list.
Exactly. The sources showed calculating the mean and median of some sample failed login data that way. Is there another way to import? I think the sources mentioned one.
Yes. If you only need specific things from a module,
Mm.
you can use from module name, import function name.
From import.
Right. So from statistics import mean. Or if you need multiple, from statistics import mean, median,
And the advantages.
you can then call the function directly by its name without the module name, dot prefix, just mean my list, instead of statistics.mean my list.
Okay, that's a bit cleaner if you only need a few things.
It can be. And just quickly, beyond the standard library, there are countless external libraries for more specialized tasks, like requests for web interactions, maybe for threat intel feed.
And those you have to install first.
Usually, yeah. Often using a tool like pip, you might see %pip install some library before you can import some library.
Right, so modules and libraries extend Python's power enormously. You just need to import them to tap into that functionality.
That's the essence of it. Which brings us nicely to the last major topic, making sure our code isn't just functional, but also, well, readable and correct.
Yeah, this seems super important, especially if you're working on a team or need someone else or your future self to understand your security scripts.
Absolutely critical. Readability isn't just nice to have. It aids debugging, collaboration, and even finding potential flaws. Comments are a big part of this.
The notes you leave in the code.
Exactly. Python ignores them, but humans reading the code rely on them. Single-line comments start with hashtag. Keep them concise, maybe explaining why you're doing something complex.
And multi-line comments.
You can use hashtag on consecutive lines or use triple quotes like this. These triple quoted ones are called doc strings, and they're standard for documenting functions, explaining what they do, their parameters, what they return.
So doc strings are like the official explanation for a function.
Pretty much.
Right.
Really helpful. Then there's indentation again.
We mentioned it for function bodies, but it applies elsewhere too, right?
Oh, yes.
Yeah.
If statements for loops, while loops, anytime you start a block of code associated with a statement ending in a colon, the block needs to be indented.
And the standard is 4 spaces.
That's the strong recommendation from PP8, the Python style guide. Consistency is key. It visually shows the code's structure. Bad indentation makes Python code almost impossible to read correctly.
I can imagine. And finally, just getting the syntax right in the first place.
Seems obvious, but it trips people up. Remember basic rules. Strings need quotes, like this or this.
But numbers don't. Attempts 8, 5, not attempts equals 5. Same for true and false.
Exactly. Lists use square brackets with commas between items. And don't forget that colon dat at the end of header lines for if, while for, and def.
That colon is easy to miss, but Python won't run without it, right?
Nope. Syntax errors will stop the whole thing. So meticulous attention to these details is fundamental. Comments explain, indentation structures, correct syntax makes it run.
It all works together for code that's effective and understandable. The sources also mention a reference guide and glossary.
Yeah, handy resources for double-checking syntax or terms as you're learning or coding. Always good to have nearby.
Okay, so let's recap this deep dive. We've covered creating your own functions using Python's built-in ones,
Handling data with parameters, arguments, return values, and understanding global versus local variable scope.
importing modules and libraries like statistics to add more power.
And finally, the absolute importance of clear, readable code using comments, proper indentation, and correct syntax.
And looking at this through a cybersecurity lens, all these skills seem directly applicable. Automating tasks, analyzing data, understanding potentially malicious scripts.
Definitely. Writing clear, modular Python is a huge asset in security. It lets you build tools, analyze faster, and collaborate more effectively.
Which leads to a final thought for you, the listener. How can you take these concepts, functions, modules, readability, and apply them right now?
Yeah, think about which of these could help you tackle a security challenge you're facing, or maybe even start building a simple security tool you've been thinking about. What are you curious to explore next? Something to ponder.